Hello and welcome. I'm Bob Meyer, President of Progressive Perspectives, and I'd like to welcome you to the International House for this very important talk. I invite you to become acquainted with our group, Progressive Perspectives. We organize speakers, events, and conferences on the key issues of our day. I'm sure you got a flyer as you came in. Speakers for our events in January are Dean Baker, the economist, talking about what happened and what can we do about it, and Senator Bernie Sanders, who, by the way, it will interest many of you that he's writing key global warming legislation in the Senate, and he will be here on January 10th. If you don't have information about these events, please pick up a flyer on the way out, and we invite you to sign up for our group. There were some key people who made this event happen. My good friend Max Lowenstein, who's a research scientist at the NASA Ames Research Center in Mountain View, was absolutely crucial every step of the way in making this happen. Inez Fung, who you'll hear from in a minute, who's co-director of Berkeley Institute of the Environment, just arranged to get this wonderful hall and has been working nonstop for the past week on this event. And also Carlette Altamirano at BIE has absolutely been invaluable at putting this all together. And I'd like a special thanks to Jesse Simons of the Sierra Club, who is partly responsible for this wonderful turnout. So next, it's my pleasure to introduce Inez Fung. Inez Fung is the founding co-director of the Berkeley Institute of the Environment. She's a professor of atmospheric science in the Department of Earth and Planetary Science and the Department of Environmental Science, Policy and Management. She received her degrees in applied mathematics and meteorology from MIT. And then she came here in 1998. She joined the Berkeley faculty as the first Richard and Rhoda Goldman Distinguished Professor in the Physical Sciences, and she was founding director of the Berkeley Atmospheric Sciences Center. Inez has known Jim Henson and worked with him for a long time. She joined him at the Goddard Institute of Space Studies after her postdoc at NASA Goddard Space Flight Center. And she remained in Jim's group for the next 15 years, where she started modeling the global carbon cycle. It's interesting to me that Inez is the subject in a new biography series for middle school readers called Women's Adventure in Science, that was launched by the National Academy of Sciences and she's featured in a cartoon series based on that subject. I think we should send that to Lawrence Summers, don't you? And Inez just does really great work, and here she is, Inez Fung.
Thank you very much for being here tonight. It's my great pleasure to introduce to you Jim Henson. And I think, judging from the audience, most of you have read about Jim. But when I met Jim, I thought he was an alien. I always thought he was an alien. He was an Iowa farm boy living in Manhattan. And his early work was on Venus, and he worked with Van Allen of the Van Allen radiation belt. So I just thought he finally came down to Earth. And when he came down to Earth, it was a big splash with all the starting work on climate modeling. So when I joined Jim's group, the modeling was just started. But many of you know in 1979 was the first, many of you know about the IPCC, the Intergovernmental Panel for Climate Change, but in 1979, the National Academy of Sciences had a report which preceded the IPCC, and there Jim's model was one of two that did the first calculation of doubled CO2, and that was included in that particular report. Since then, Jim has been relentless and works harder than most people, not just publishing the science, and the science, I think the science hasn't changed, Jim, in 25 years. Saying the same thing, the climate is changing, CO2 is the forcing, but also Jim has been testifying in Congress with then Senator Gore, and we would know that Jim would be testifying because on Sunday the typist would come in, and if the red pencils came out, then the typist would change. He would go down and testify as a private citizen. So it took me quite by surprise. And so 1988, he was the first one to say, on a very hot summer day, he testified in Congress, I think, on Tim Wirth's committee, that the greenhouse warming is here. That caused a lot of consternation. The academic community says, how do you know your statistics? You can't be 99% sure. The NASA powers, I think, were unprepared for the press that came in. And Jim has been doing the same thing ever since, sticking up, not just doing the science and leading the pack on how we think about the climate system, the urgency of it, the implications of it for all of us, but also setting example for all of us about scientific integrity. So you've read about all of that in the New York Times and everywhere else, so I won't repeat that. So it gives me great pleasure to have Jim here on my new home turf at Berkeley. So Jim.
Thanks very much, Inez. Actually, there's no better example of scientist than Inez and working with young people, and but in any case, I have a lot of things to talk about, so let me get started. I always need to start by pointing out this gap that exists between what is understood about global warming by the relevant scientific community and what is known about global warming by the people who need to know, and that's the public and policymakers. And it's understandably hard for the public to realize that we could be at a point of a planetary emergency. But in fact, we are, and the reason that can be is because of the inertia of the climate system. The ocean is 4 kilometers deep. It takes it a long time to change its temperature in response to a forcing mechanism. And as a result of that, there's a lot more climate change that's already in the pipeline due to gases that are in the atmosphere, even without any additional gases. And that combines with the fact that the climate system has tipping points. You can push it beyond tipping points, and then the dynamics of the system will take over, and the changes will occur out of your control. And an example are the large ice sheets. If they once begin to disintegrate, then move down a slope to the ocean, then it's too late. You can reduce the amount of CO2 in the atmosphere, but the dynamics will have taken over. Now, the bad news is that what we've realized in just the last few years is that at 385 parts per million, which is the amount of CO2 in the atmosphere now, that compares with 280, which had existed for 10,000 years before that, we've already moved into a dangerous territory. And we are going to need to actually reduce the amount of CO2 in the atmosphere. And that's still possible if we get started promptly. And there would be other benefits of doing that. Now, since we just came out today with analysis of the global temperature for 2008, I should mention that. This point is actually, the 2008 point is based on just 11 months of data, but it's not going to change very much with December data. And this year, 2008, is the coolest year since year 2000. That, however, does not indicate a new trend. It's a natural fluctuation which is associated with the oscillations of the tropical Pacific temperature. These maps show the temperature anomalies relative to the period of climatology, 1951 to 1980. And this map on the left is for year 2008, actually the last 12 months, starting in December of 2007. And this map is for the first 7 years of this century. And yellows and reds are warmer than the periods of climatology. So you can see that averaged over several years, the planet is getting warmer everywhere. And the warming is larger over land than it is over the ocean, because the ocean has only partly responded because of its inertia. And the warming is larger at high latitudes than low latitudes because there are amplifying feedbacks at high latitudes. In particular, when ice and snow melts, it exposes a darker surface which absorbs more sunlight, and that causes more warming. And it's larger in the northern hemisphere than the southern hemisphere, mainly because there's more land in the northern hemisphere. But in 2008, we had, at the beginning of the year, a strong La Nina, which is the cool phase of this southern oscillation. So the Pacific Ocean was cool, and actually the United States is not unusually warm. It's fairly similar to the 1951 to 1980 average, but the rest of the world is just as warm as it has been for the last 7 years. Now, but if you remember back on my first graph, the amount of warming was 0.8 degrees Celsius, with 3/4 of that warming occurring in the last 30 years. Well, that's about 1.5 degrees Fahrenheit, and over land areas it's about 2.5 degrees Fahrenheit. But that is still small in comparison to weather fluctuations, which can be 10 or 20 degrees from one day to another. So you can ask the question, why should we be concerned about human-made climate change? We know very well that there have been huge climate changes in the past, much larger than the global warming we're talking about. And so isn't it arrogant to think that humans actually control climate, or that we know enough to say that today's climate is the best one for the planet? And these were statements made on National Public Radio by my boss's boss's boss, the NASA administrator. And they are reasonable questions, actually, for a well-educated person to ask. We scientists should do a better job of making clear what the answers are. And we do have some very strong basis for our understanding, and in particular, the strongest, most reliable information comes from the Earth's history, how the Earth responded in the past to changes in the boundary conditions, such as atmospheric composition. And also, we now have pretty good global observations of what's happening now in response to the changes that are occurring in the atmosphere. And climate models also are helpful in interpreting that data, but they certainly rank number 3 on that list. And they are useful for projecting into the future. But one thing we need to, we can use is the information we get from the paleoclimate records for the last several 100,000 years, because we have quite detailed, precise data This is the temperature near the South Pole over the last 400,000 years, and you can see that the temperature oscillates between the warm interglacial periods and goes into ice ages. And we've been living now in the Holocene, a warm period, for the last 11 to 12,000 years. 20,000 years ago, during the last major ice age, the planet on the average was about 5 degrees Celsius colder, about 10 degrees at the poles. And this information comes from an ice core drilled in the Antarctic ice sheet, which is built up by snowfall piling up year after year and being compressed into ice. And as it's compressed into ice, it traps bubbles of air, so you can sample the atmosphere that existed as a function of time over this whole period. And what we find is that there's more or less simultaneous with the temperature changes are changes in the atmospheric methane and carbon dioxide. And we can use this information and the information on the changes on the Earth's surface. During the last ice age, there was an ice sheet that covered Canada and reached down and covered Seattle and Minneapolis, New York City. Enough ice was trapped in that ice sheet and another one on Eurasia that sea level was about 110 meters, 350 feet lower than what it is today. But we know that the change in the surface albedo due to the surface changes is equivalent, it's about 3.5 watts per meter squared averaged over the planet. And the changes in the greenhouse gases cause a forcing of about 3 watts per meter squared. A forcing is a perturbation of the planet's energy balance, which would tend to change the planet's temperature. So for example, if the sun were to become 1% brighter, that would be a forcing of 2.4 watts because the Earth absorbs about 240 watts of energy from the sun. In the case of greenhouse gases, if you add more of those to the atmosphere, it makes the atmosphere more opaque in the infrared part of the spectrum, and that reduces the amount of heat that the planet emits to space because the radiation arises from a higher level where it's colder. And anyway, these two forcings of 6.5 watts maintain a planet which is 5 degrees colder. That implies a climate sensitivity of 3/4 of a degree for each watt of forcing. And that means that doubled CO2 should give you an eventual warming of about 3 degrees Celsius because doubled CO2 is a 4-watt forcing. And we can check that this sensitivity is universal in the sense that it applies at all time because we know how sea level changed as a function of time. That tells us how big the ice sheets are, so we can calculate both the ice sheet, the surface albedo forcing and the greenhouse gas forcing, and multiplying those by 3/4 of a degree, we get a temperature change which agrees well with the actual temperature change. It's these climate oscillations are actually instigated by changes in the Earth's orbit. And so, for example, because the Earth is tugged at by Jupiter and Saturn because they're heavy, and Venus sometimes comes close to the Earth, so it perturbs the Earth's orbit slightly. And the tilt of the Earth's spin axis, for example, will wobble by plus or minus 1 degree. And when it's tilted more, that exposes the poles 6 months out of phase, both poles, to more sunlight, and that tends to melt ice at the high latitudes and makes the planet somewhat warmer. And when it gets warmer, the ocean will release carbon dioxide, just as your Pepsi will release carbon dioxide if it gets warmer. That's part of the reason. And so as a result, the changes in the greenhouse gases are actually a feedback in this case, but nevertheless, the greenhouse gas changes and the surface albedo changes are the mechanisms that cause these very large climate changes in response to a very weak forcing. And now humans have entered the game, and we have increased the amount of CO2 and methane far outside the range that they have been in for millions of years. And the Earth is beginning to respond to that, but it takes time for it to fully respond. It's also useful to look at the Earth's history on longer time scales, partly because we can then see examples of where the greenhouse gases change first and the climate is changing in response to that. But in particular, the last 65 million years, the so-called Cenozoic era, is a good time to look at because we know that the dominant mechanism for climate change on this time scale is changes in atmospheric CO2. Because if we go back 50 million years, the amount of CO2 in the atmosphere was of the order of 1,000 parts per million. That compares to 280 parts during the warm interglacial periods and about 170 in the ice ages. So those large variations of CO2 represent a forcing of about 10 watts. Well, the other mechanisms, like the changes in the brightness of the sun is a well-behaved main sequence star, which is burning hydrogen to make helium, and it's slowly getting brighter with time. But in 65 million years, its brightness increases 0.4%. That's a forcing of about 1 watt. And the continents were already close to their present position 65 million years ago, except India, which was still south of the equator, and it was moving north at a rapid rate of about 20 centimeters per year. And that is the major reason why carbon dioxide in the atmosphere was changing, because the amount of carbon dioxide in the atmosphere naturally is determined by the balance between the source of CO2, which is volcanoes, and the sink of CO2, which is primarily weathering, which chemical reaction and the sediments that are carried by the rivers to the ocean deposit carbonates on the ocean floor, and that takes CO2 out of the atmosphere. But those two processes do not need to be in balance at any given time, depending upon what the volcanoes are doing, what the continental drift is doing, which determines the volcanoes. And in particular, India was moving through this so-called Tethys Ocean, or now the Indian Ocean, which had long been the depot center for the major rivers of the world. So that ocean floor was carbonate-rich, had carbonate-rich sediments, and as India was moving through the Tethys Ocean, the amount of CO2 was increasing and the planet was getting warmer until India crashed into Asia and began to push up the Himalaya mountains and the Tibetan Plateau. And so when that happened, then that source of CO2 is diminished, and the sink, the weathering of the Himalaya mountains, began to draw down the CO2, and the planet cooled off until it got to a point where Antarctica, and by the way, in all this time period, there's no ice on the planet. It was so warm. The deep ocean at a temperature as much as 12 or 13 degrees. Now the deep ocean temperature is close to 0. But when it got cold enough that ice and snow began to form on Antarctica, then you suddenly got Antarctica glaciated, and the planet cooled off even further. But there are two interesting, relevant conclusions from this Cenozoic era. One is that the natural imbalance between the source and sink of CO2 is of the order of 1/10,000th of a part per million per year. And over 1 million years, that rate gives you a change in CO2 of 100 ppm, which is a big forcing. But if you compare that to the human-made rate of change of atmospheric carbon dioxide, well, humans are 4 orders of magnitude more powerful than the natural process. So although the NASA administrator was right, there were huge climate changes in the past, even no ice on the planet, sea level 75 meters higher. But the rate of those changes is very slow in comparison to what humans are doing. So humans are now in control of the system. And the other interesting point is that, well, how far did CO2 have to decrease before ice began to form on Antarctica? Well, it was to approximately 450 parts per million. So for us to think that we can burn all the fossil fuels and increase CO2 to 7 or 8 or 900 ppm is crazy. We would head the planet toward the ice-free state. It would take a while to get there. The ice sheets don't respond immediately. But we would produce, we would create havoc and create a different planet. Now, all the countries, or about 170 countries, agreed to the Framework Convention on Climate Change in the early 1990s, which had the objective of stabilizing the greenhouse gases at a level that would prevent dangerous human-made interference. But that imprecise phrase has never been defined. What is dangerous? I think that the principle at the top of the list of the metrics should be extermination of species, because that's irreversible on any time scale we can think about. There have been several large warmings in the Earth's history of 5 degrees Celsius or more, and each of them was accompanied by mass extinctions of more than half of the species on the planet, and over hundreds of thousands of years, new species evolve. But on any time scale that we can imagine, it would be a much more desolate planet if we drive a large fraction of the species to extinction. And likewise, ice sheet disintegration is irreversible on timescales less than thousands of years. And as I mentioned, there are tipping points. You can reach a level at which you're going to eventually have the problem, but you may be able to overshoot for a while before you reach a point of no return in which the dynamics of the system takes over. An example is the Arctic sea ice, where we probably have reached the tipping point. The amount of sea ice in the Arctic at the end of the summer fluctuates from year to year depending upon the weather, but it has been decreasing since we began to make measurements in the late 1970s. And 2 years ago, it suddenly decreased. So it's not much more than half of what it was a few decades ago. And the amplifying feedback there is that with the loss of that ice, then the Arctic Ocean absorbs more sunlight, and that causes it to get warmer, and we're going to melt more ice. So probably within the next couple of decades, we're going to lose all of that ice. But that's a reversible tipping point, because if we restored the planet's energy balance, or slightly better, made it slightly negative, then the ice would grow back. We would probably have to reduce CO2 to something like 325 to 350 ppm if we wanted to stop the ice from melting. Another criterion is the stability of the ice sheets. The area on both West Antarctica and Greenland that melts in the summer fluctuates from year to year depending upon the weather in the summer, but the area has been increasing. And in 2007, the area with melting was really very large. That was the record year. And that meltwater in general doesn't make it to the edge of the ice sheet. It goes to a low point on the ice sheet, burrows a hole in the ice sheet, and it goes to the base of the ice sheet where it lubricates the ice and speeds up the discharge of giant icebergs to the ocean. And there had been the argument that, well, global warming will cause the ice sheets to grow faster because it makes the atmosphere hold more water vapor, you get more snowfall in the winter. Well, common sense would tell you that as the planet gets warmer, we're probably going to get smaller ice sheets. But that now has been proven very well by this spectacular satellite, GRACE, which measures the gravitational field of the Earth with such a high precision that you can determine the mass of the Greenland ice sheet and the Antarctic ice sheet. And during the winter, the ice sheet gets heavier, and then during the melting season, it loses mass. But overall, it's losing mass at a significant rate, which in the last 2 years has been a rate of about 200 cubic kilometers per year, which is still not a big sea level rise. The sea level is now rising at a rate of about 3.5 centimeters per decade, so a little more than a foot per century. But that's about double what it was 20 years ago. So the rate is increasing. If we wanted the ice sheets to be stable, well, we know that 385 is too much because we can see that both West Antarctica and Greenland are not stable. And looking at the Earth's history, we would say that ice sheets of the approximate size of the current ones probably require CO2 to be not more than about 300 ppm. But, okay, here's another phenomenon which gives us a quantitative estimate on what's dangerous. One of the dynamical phenomena that's expected to accompany global warming is an expansion of the overturning Hadley circulation, the rising motion in the tropics and the subsidence in the subtropics, which makes the subtropics. That expands as the planet gets warmer, expands poleward. And empirically, it's been observed that on the average, it has already expanded by about 4 degrees of latitude, which is beginning to affect the southern United States and the Mediterranean region and Australia and parts of Africa, and is part of the reason why Lake Powell and Lake Mead are only half full, and the reason why the increased dryness has contributed to this phenomena of increasing forest fires, which have increased about a factor of 4 in the western United States. And, well, another very important practical effect of global warming is the melting of mountain glaciers all around the world. These provide fresh water. The rivers originating in the Himalayas and in the Rocky Mountains and the Andes Mountains provide fresh water to hundreds of millions of people. And the glaciers allow the rivers to have a good supply of fresh water all through the summer and fall. The spring snowmelt will always be there, but if you only have the snow, that goes pretty quickly, and this spring is coming earlier and earlier. So, and as these glaciers are melting, you're getting some extra fresh water, but once they're gone, then the fresh water in the summer and fall, the rivers will run much drier. Another impact of global warming is on the life in the ocean, about 1/3 of which is associated with coral reefs. And the coral reefs are under stress for several reasons, but 2 of those reasons are associated with the increasing CO2. The one is the acidification of the ocean. As it absorbs more CO2, it becomes more acid, and it can dissolve carbonate shells, and it affects also those species that have carbonate skeletons. And also the warming temperature of the ocean is damaging to coral reefs. So that on these sort of criteria, we estimate that the target CO2 that we should be aiming for is no more than 350 parts per million. And it's probably less than that, but we don't really need to determine an exact number, because once you've said it's 350, which is less than what we have today, it already tells you the direction you've got to go, and you can fine-tune that sometime in the future after we've started moving in the right direction. If we want to preserve the planet like the one on which civilization developed, we need to have CO2 less than 350 parts per million. And the difficulty with that is associated with the long lifetime of CO2 in the atmosphere. When we put a pulse of CO2 in the air by burning fossil fuels, it begins to disappear quite rapidly. And after it's half gone already by about 20 years or so. But then, and most of it is going into the ocean, but then the ocean begins to resist taking up the rest of it because the CO2 can come back out of the atmosphere, out of the ocean. And until the CO2 that has been taken up by the ocean is deposited on the ocean floor as carbonate sediments, the ocean will not take up all of the CO2 from the atmosphere. And that takes thousands of years. So after 1,000 years, roughly 20% of it is probably still in the atmosphere. And that tells us that we cannot burn all of these fossil fuels because we would end up with several hundred ppm of CO2 in the atmosphere and headed the Earth toward an ice-free state and a very chaotic state for a few centuries. But it's very difficult to prevent the purple portions of these bars are the parts that have already been burned and put into the atmosphere. And there's uncertainty about how much there is left in the ground, depending on whose estimate you take. But most people think we're probably close to peak oil, which means we've used about half of it. And it's impractical to capture the CO2 coming out of the tailpipes of vehicles, which is where the oil is used. But the biggest potential source, and the one which we could control, is coal. And that's the one which we have to cut off if we're going to keep a planet that looks like the one we have. And so we either have to decide to leave the coal in the ground or else use it only at power plants where we capture the CO2 and sequester it. So if we had a moratorium on new coal-fired power plants and phased out the existing ones over the next 20 years, then CO2 would peak at something between 400 and 425 ppm, depending upon whose estimate is more accurate for the undiscovered reserves of gas and oil. And if we did some things like improved our forestry and agricultural practices, we could bring down CO2 more rapidly than it would come down otherwise and get back below 350 ppm. But the key thing is you've got to phase out the coal quickly, because if we just continue for another decade or so, it'll become impractical to get back to 350 ppm. There's only so much CO2 we can take up with reforestation and increasing amount in the soil. So the challenge is, we are going to have to figure out how to live without fossil fuels someday. Anyhow, these are finite resources, so why don't we do it sooner and leave some of the coal in the ground? It's very dirty stuff anyhow. It's polluting the oceans with mercury and mountaintop removal, and there are a lot of, and the air pollution is killing several 100,000 people per year, mostly in China and India, but 30 or 40,000 in the United States. The way I look at it, it seems to me that there's a basic conflict between the fossil fuel special interests and the young people in nature. I think that the two things that are essential if we're going to solve the problem, we've got to phase out the coal emissions, and we've got to put a price on carbon emissions. Because we're going to have fundamental transformations to a post-fossil fuel society, and you have to give the incentives for that. And I think the only way that will work is if you put a tax on carbon, and the only way the public will accept a tax that is big enough to force the changes in society is to give the money back 100% to the public on a per capita basis so that the person who does better than average in reducing his carbon emissions will actually make money in the process. But with the knowledge that this tax rate is going to continue to increase, it will provide very strong incentives for innovation, for entrepreneurs to develop non-carbon sources of energy and energy efficiency. And we have to avoid using unconventional fossil fuels. I didn't include a bar for them, but there's actually more carbon in tar shale and tar sands than there is in coal. And there are people who think that we can squeeze that oil out of those substances. But if we do that, the ball game will be over. But it's easy to say, okay, we're going to phase out coal, but you've got to replace that with something else, because the United States has 50% of its electricity from coal, and China and India are even much more than that. Well, at the top of the list of the things we need to focus on is energy efficiency, because there's a tremendous potential for that, and it does require both standards in building construction and appliance efficiency, et cetera, but also a carbon tax. Because otherwise things like building standards are not enforced. It's very difficult to enforce them. You need a price incentive to be a self-examining way of getting the thing enforced. But also, we need to find out how much energy we can get from the renewable energies. And in order to make them work and move the energy around a country, we need an improved electric grid. I think, I think the plan that Al Gore has been talking about is, hoping that you can do everything with these soft energy sources, and maybe that will work in the U.S. Maybe it will work everywhere, but I think most people are skeptical about whether China and India are going to get all of the energy that they want from renewable energies. So we should at least be doing the R&D on fourth generation nuclear power, in my opinion. The current nuclear power is the light water reactors, which end up leaving 99% of the energy in a waste pile, which has a half-life of 10 or 100,000 years, almost impossible problem to deal with. The advantage of the fourth generation nuclear power would be that it would burn this fuel, the waste, and so solve the waste problem, which makes more sense than trying to find a place where Yucca Mountains or wherever you would store the waste. And it also would mean that you don't have to mine uranium for 1,000 years, because there's enough energy in the nuclear waste and in the weapons grade material that we have to provide our electric power for many centuries. We also should do the research and R&D on carbon capture and sequestration. I'm not convinced we'll ever have clean coal, because it's very hard to capture the mercury and avoid the problems at the mining sites. But the carbon capture and sequestration would be useful at power plants where you burn biofuels, and then you can capture the CO2 and sequester that, and that way you would draw down the amount of CO2 in the atmosphere. And as I mentioned, I think a carbon tax and 100% dividend is necessary in order to provide the economic incentive to phase out fossil fuels. And again, the public won't accept this if the government is putting a big tax and then taking the money to Washington and deciding how to spend it. So that's why I say it has to go back 100% in dividend. And now I want to say something about this intergenerational justice. This is my newest grandchild, who Jake has not done much of anything to cause global warming. And in fact, he can't even walk yet. He only crawls, but he crawls quite fast. And when I snapped this picture, he looked up as he was crawling across the room. But Jake, you know, my parents lived to 90 years of age, so I think Jake will probably live through most of this century. So he's going to feel the effects of what we're doing now. And our parents had the defense that they didn't know that they were causing a problem for future generations. But that is no longer a viable argument. Now we understand what the situation is. And I think young people are finally beginning to understand it and are beginning to make a fuss, which is appropriate. But the problem is, and I've gone to several different countries around the world, and I know what the politicians there are saying, and I know that they seem to be very strongly under the influence of business interests in their country. Young people, you know, don't have as much clout in the capitals around the world. And as I say, the animals don't help much. But there are cases now. This is the Kingsnorth case in the United Kingdom, where the Greenpeace activists occupied this power station and were painting on the outside of Gordon Bennett when they got interrupted by the police. Gordon Brown is the prime minister, and they're planning to build a new, big, huge coal-fired power plant there. And they were arrested and charged with $65,000 or pounds of damage. But the jury found them innocent on the grounds that they were protecting property of greater value, namely the earth. But, I mean, that's nice, but it doesn't solve the problem. I mean, it did send a message to the British politicians, but they still have not made up their mind about whether they're going to build that Kingsnorth power plant. And in the U.S., I would say we're even not this. I testified at this case, and it was peers. It was common people from the Kent area, 9 women and 3 men, and they were very interested in this climate story. But then when I went to Wise County, Virginia, thinking I was going to testify on behalf of some young people who were arrested there for blocking a power plant, well, the lawyer there convinced them that they had better plea bargain because the jury pool was very unfavorable. And they probably would have ended up there. And they were charged with 14 counts, which would have been 14 years in prison if they had lost. So, you know, we're not there yet, but yet there are going to be more protests. I can tell you there are a lot of young people who are planning to take some actions with civil disobedience. Yeah. I think, you know, I think that I should probably stop and we can take questions. Is that about the right amount of time? Okay.
Now, you all should have received cards for questions. I'd like to point out that we're also on a timeline here. Jim has to catch a red-eye back to New York, so to be more efficient, we'd like to do the Q&A with pre-submitted questions by people who have worked to put this event together, and then the questions that you're you're turning in. I'd like to start with a question about wedge theory. And let me just say what that is. Here's the question. You have urgently warned that the world has to get down to 350 parts per million by 2050. We just heard about that. Getting there is such an enormous challenge that some have said it's impossible. The conceptual framework of wedges has been suggested by Sokolow and Bakala, in which a wedge is a particular energy reduction or replacement strategy that starts small and increases over time. It has been calculated that we would need something like 18 50-year wedges to accomplish the 350 parts per million goal. Yet we can't seem to get even one 20-year wedge in place. Could you talk more about such prognoses?
Yeah, well, I think the paper that you refer to is a useful thing for affect our thinking. But in fact, wedges, you know, what will actually turn out to be the substitutes for the fossil fuels is going to depend on well, innovations, but also many things which are actually available now. You know, we could be 50% more efficient in our buildings right now with the technology that we have, but we don't have the price incentive for doing that. I think you have to let the market decide what the wedges are, and some of the wedges are going to turn out to be much bigger than they talk about, and some of them will turn out to be small. Let the market decide that. But if you have the price incentive, you'll be surprised at how once things begin to, there are tipping points in human society and in also, and we will, as I said, we will eventually have to go to a non-fossil fuel based society. And I think the wedges that they could think of, you know, and if you ask Steve Bakala, he says, well, there are still more wedges, but they got tired after 10 or 12 of them. But it's hard to predict which ones are going to be the most effective. I'm sure there are things we haven't thought of yet that will be part of the solution. But you need a price incentive to make those happen.
I guess we can just This is a question from a member of the business community. The U.S. Chamber of Commerce and other businesses as usual types are still the dominant business voices and are major patrons of our congressional representatives. There are new business voices emerging today that don't have near the financial capacity for lobbying and other means of purchasing votes. Are you willing to be a resource for and spend time with these new business voices in order to help mobilize millions of these folks to weigh in on the right side of climate and energy public policy during the 111th and 112th Congresses?
Yeah, I try to choose my spots. And I have to evaluate one against the other as to which one's going to be most effective. Now, you're quite right that the business community so far has been mainly resisting, or many of them will now talk. They have this greenwash. They will put advertisements that they're doing things, but until they're given the guidance and the incentives, they're not going to. They eventually, so-called captains of industries, will be key part of the solution, and will make things move fast once they have the incentives. But our government has not given them the incentives. Instead, our government has tended to respond to those lobbyists who don't want to make changes. And unfortunately, the democratic process has not worked as well as it should, because money talks when it's supposed to be one person, one vote. Now, you should be encouraged by this last election because of the so-called 12 dirty dozen, the dirtiest, those who had the worst voting record on this type of issue, as identified by the League of Conservation Voters, 7 out of the 12 incumbents lost, which is remarkable. Incumbents have enormous advantage in the election. And with the result on the presidential level, I think there's a very good chance that Congress will, that things will begin to happen. But you're right that the business community has got to be made to be part of this solution and made to realize that they can't get out of doing it by buying off politicians.
We've got a question about reforestation. What do you think about the idea of a massive reforestation program? Is it possible? What would be the most effective way of doing it, and how much of an impact would it have?
Yeah, one of my co-authors knows much more about this than I do, but we estimate that with reforestation, primarily on marginal lands, which are not good for food production, there's a tremendous potential for storing carbon, possibly as much as approaching this 50 parts per million that we need to draw out of the atmosphere somehow. So that's actually the biggest part we've looked at this question of both forestry and agricultural practices, and there is also potential for storing more carbon in the soil. Right now, the way we plow up the soil, it actually releases carbon to the atmosphere, but with minimum till agriculture and working biochar into the soil, there are the possibility of storing quite a bit of carbon in the soil, as well as reforestation of areas that it makes sense to reforest. So I think that's a big part of the solution, but the problem with it is it's finite. So we have to cut off the coal soon. If we do that, then these other measures would allow us to get back to 350, but we've got to cut off the coal pretty quickly.
I have a question about consumption. We have a society that's based on consumption, and now we have a failing economy. There are stimulus packages that will encourage even more consumption. As a cultural issue, what are your feelings about how to address this problem of wildly encouraged consumption?
Yeah, well, technically, the climate problem is primarily a carbon problem. I've emphasized that because the carbon is the thing with the long lifetime. There are other gases which will help us a bit to solve the problem if we once can get the carbon under control. It doesn't, we don't need to say that people have to go back to simpler, less energy-intensive lifestyles in order to solve the problem. May not be a bad idea to do that, but the fact is, what we really need is energy sources that don't produce carbon, and that's certainly possible. We should be using energy much more efficiently. The fact that we don't make we actually subsidize oil and coal, and we don't make them pay for the damage that they do to the atmosphere and human health, and so we're very wasteful. And it's certainly true that by reducing our consumption, you can make some reduction in those emissions, but the real issue is not, I think, convincing people not to consume, but it's developing the sources of energy that are clean. And I mean, it will be a tremendous, if we can get beyond the fossil fuel society, we can have a clean atmosphere, and we can stop polluting the ocean with the mercury and things, and it will be a better world. And whether people want to fly around the world or not, I mean, that's, they can do it as long as they're not releasing carbon, as far as I'm concerned.
Several people seem to want to know what you think about the appointments of the Obama administration so far in regard to climate change policies. And I would add, how can we, people here, including grassroots activists, young people, people out of power, establish a conversation with the people in the administration about these things that affect, as you've pointed out, people in this room disproportionately, but we don't have that kind of say. So it's a two-part question.
Okay. Yeah, well, for the first part, of course, you're optimistic at the beginning of a new administration, but this, I mean, so far the appointments seem to be remarkable, of which, from the standpoint of this problem, the outstanding one is, of course, Stephen Chu, just the qualitative difference of where people are being appointed clearly on the basis of ability, and very smart people. I mean, we've just had such an example of where people are appointed on the basis of loyalty and how, rather than ability, and the disasters that causes were so obvious. But in any case, I think everybody's delighted by the choices that have been made so far, and I hope that they will have in the case of the Energy Department is really very critical. I think we have to have an objective look at what is really possible, rather than just having a standoff where people say, well, we will do everything with renewable energies, and then if it doesn't, we will end up with just coal plants going on, because people are not going to turn off their power. They're not going to allow blackouts. We've got to have energy. So anyway, I'm very encouraged by those appointments. I could not have thought of a better person in the world than Chu for that job. But your other thing, how do you get your voice heard? I think that the last several months, last year, I had a number of interactions with organizations like Power Vote, young people who they registered enormous number of new voters, young people, and they did have an impact. And they need to continue that, and they are continuing that. And as I say, I'm also aware of some organizations like 350.org and other organizations that are planning to make their voices heard on this subject, and the more people that will join those efforts, the more effective they will be. I'm optimistic, but we'll have to see, because we're running out of time.
A couple people want to know your sentiments about cap and trade versus carbon tax, and whether cap and trade is subject to a kind of greenwashing effect, and whether it could potentially be as effective. And I would just add that it seems that some people in the Obama administration actually favor cap and trade over carbon tax. What do you think about that?
Yeah, I think that's because, let me say first that I think that cap and trade is not well suited for this problem. Cap and trade worked in the case of SO2 emissions because those came from power plants, a finite number of power plants, and you either installed the equipment which reduced your sulfur emissions, or you didn't. It was easy to see, easy to monitor what actually happened. And that worked in that case. But the cap and trade, you know, you cannot, first of all, there's always a lot of horse trading and things, and there, I think the trading ends up producing some millionaires, but all of the people who make money out of that, who pays for that? Where does that money come from? It comes from the public. And the public will get very fed up with the impact of that on their energy prices when they see people making big money out of it, and it will be a subject to the usual lobbyists. You're going to be hiring a lot of lobbyists. It's the wrong way to solve the problem, and it doesn't. It's already been proven in several cases it doesn't work. I mean, in effect, that's the Kyoto Protocol approach. You set some targets, some caps on a country, and they're supposedly going to reduce their emissions. Well, they find ways to get out of it. Japan was the best example. They took the strongest goal, but then if we actually, and nobody ever said anything about this, but last year I made graphs of their CO2 emissions, which is easily available. It just comes from oil, gas, and coal. And their CO2 emissions increased fairly strongly because their coal use increased. Well, they still satisfied the cap. They just did it in ways like purchasing clean development mechanism rights in China, which supposedly would reduce China's emissions, but China's emissions increased very rapidly. And then you trade it with other things. The thing that has to be reduced is oil, gas, and coal. So you should have a tax on them at the wellhead or at the port of entry, and that tax has to be rising over time, and that will catch all of it. Otherwise, if you capture part of it, you reduce the amount used in some activity, whether it's utilities or whatever, even if that's successful, it reduces the demand for that fuel, and it becomes cheaper, and somebody else will use it for something else. The country that mines it will use it on their own inefficient vehicles or whatever. So I just don't think cap and trade is the right thing, and it's too bad Obama's advisors are pointing him in that direction, and I'm in the process of writing him a letter.
Are you going to send us a copy?
Am I going to send it what?
Are you going to send us a copy of the letter?
Oh, yeah. Obviously, because he may never, whether he's going to read it or not, you have to get the ideas out and have people talk about them and discuss them.
Got a question about clean coal technology. The question is there such a thing?
Well, there certainly isn't now. It was one of the mechanisms of greenwash, or just to make people believe that they're working on it. And it took them 7 years to decide where they would make the first plant in Illinois, and then they canceled the plans because utilities did not want it, and coal companies did not want it, because they would rather, they're making a lot more money by burning coal without any constraints. And it's very hard to capture the mercury. So even the plants they're talking about don't capture all the mercury, they reduce the amount. And it's hard, if you're going to mine coal by cutting off the mountaintop, that creates huge environmental problems. I really think coal is best left in the ground, but as I said, I think having an R&D program in carbon capture and sequestration is useful. Even if we decide to leave the coal in the ground, you can still make use of the carbon capture with biofuel-powered plants.
A few questions about biofuels, and just you want to say a little bit about that whole area?
Well, I think that biofuels may be useful but done in a very different way than the politically motivated corn-based ethanol, which really doesn't do any good for the environment and also doesn't do any good for a lot of people in the world by raising food prices. But if you grow the plants on marginal land which is not suitable for agriculture, if you do it in a way more like the way nature does, with a diverse set of crops rather than of grasses and things, rather than a monoculture, and do it with minimum input, not heavily fertilizing it, then you can do it in a way that is potentially useful. I don't think you want to try to power your vehicle fleet with that biofuel, though, but you might want it for aircraft, which right now aircraft is using only a couple of % of the total carbon emissions, and so it wouldn't require that much biofuel. So until we have something else to fuel the airplanes, it might make sense to do it that way. But for vehicles, that's such a large amount that we need something else which doesn't produce carbon.
A couple people have wanted to know whether the PowerPoint presentation you just gave will be available.
Yeah, most of it already is available, but I'm going to make available the talk that I gave in AGU today, which has these charts plus some other ones. And I'll do that probably tomorrow, at any rate later this week. And it will be on my website, which I'm not sure I got to that. By the way, this is the website. Maybe let me mention one scientific point, because I don't want to leave the impression that we have nailed down all aspects of the science. But one of the points that I mentioned in my AGU talk was this one about the aerosols. You know, the net climate forcing is a combination of the greenhouse gas forcing, which we know very well. It's about 3 watts per meter squared. But then humans are also producing aerosols, which reflect sunlight. Most of them reflect sunlight, and that causes a negative forcing. So the net forcing is something in between that, and fairly uncertain. And we've kind of been assuming that it was more of this neighborhood, close to 2 watts per meter squared, because that's what gives the best fit to the observed temperature change, given the climate models that we have today. But today I argued that I think the ocean models have a systematic error. They mix too effectively, and that reduces the response time. It increases the response time of the system such that it's causing you these are my other 2 grandchildren. And when I explained, I asked my granddaughter, Sophie, she was explaining to her brother that the net climate forcing was probably about 2 watts. But Connor could only count 1 watt. And it's fairly important to understand who's correct. if it's 2 watts, that means that, you know, we're feeling most of the effect of the greenhouse gases. But if it's 1 watt, that means the aerosols have been hiding 2/3 of the effect. And the other, then that 2/3 is going to eventually appear if we clean up the atmosphere. And the United States and Europe did begin to clean up their atmosphere. But China and India started putting out so much that they've made up the difference. And we continue to have roughly the same amount of aerosols. And we don't know, because we haven't been it's hard to make the aerosol measurements. Beginning next year, we're going to have a satellite instrument that may be able to do it. But anyway, it's sort of important to figure out who's right. And because the Faustian bargain is that by burning the fossil fuels and masking, those aerosols are masking the eventual effect. But in order to continue to mask the CO2, we'd have to get more and more air pollution. Air pollution would have to keep increasing as fast as the CO2. And pretty soon you're going to get tired of that and you're going to stop. And once you stop putting up the aerosols, they fall out within 5 days. But the CO2 stays there 1,000 years. So then you have to pay Mephistopheles. Anyway, I ended up saying that I went back and asked Sophie and Connor, now what is it, 1 watt or 2 watts? And they said they didn't know. So we have to make the measurements to figure that out. But it's one of the aspects of the science which still isn't nailed down. If Connor is right that the net forcing is only 1 watt, that's really interesting that we've got this much climate response with a forcing of only 1 watt, but that's within the range of the possibilities.
Gets the mic. Some of your potential allies here are vehemently anti-nuclear, and I'm just wondering, what would you say to them to create some understanding about the possibilities for 4th generation nuclear, and do you see a way of diffusing these objections?
Well, I think that we just have to try to be as objective as we can be. One thing that is worth pointing out is that the total amount of radioactive material that's been spread around the world there's more than 100 times more has been spread from the emissions from coal-fired power plants than from all the nuclear plants in the world, including Chernobyl and 3 Mile Island. I get now a lot of emails from people who are unhappy about the fact that I said we should look at this. And some of them just say, arg, but those who try to give me a reason will say things like, the nuclear waste, that this will produce is, but they haven't read the story. I mean, the reason that you want 4th generation nuclear power is to solve the nuclear waste problem. And then one of the other arguments that they make is that, well, this nuclear power really produces a lot of CO2 because there's been a study that showed that the mining of uranium and the processing of uranium, the building of the plant produces CO2. But again, that's the argument for 4th generation. You won't have to mine uranium for about 1,000 years. There's enough waste and nuclear and weapons grade material to provide all the fuel you'd need. But there are legitimate questions. The other thing is you want your nuclear power plants to be safe in terms of an accident. And there is the potential for more fail-safe operations with the plant that will automatically shut down rather than if there's an accident, an earthquake, or whatever. And so I think you can make a nuclear power plant safe. The one issue that is hard to have a good answer, a firm answer to, is the danger of proliferation. Can somebody get a hold of the material and use it for bad purposes? For that purpose, you need to have international controls. And I think the United States would be better off if it were at the table setting the standards and the rules and things on controlling the use of nuclear power rather than abandoning it, because there are like 6 other countries that are working on this 4th generation nuclear power. So it's not going to disappear. Nuclear power is not going to disappear from the face of the planet if we convince the United States not to have it. But I think it should be looked at objectively. And I've never said that I'm in favor of nuclear power. I think that in the event that 10 years from now it becomes clear that renewables are not going to do the whole job, then we want China and India to have options that will not destroy the planet. And it's one of the options.
Well, speaking of China and India, doesn't this all have a bearing on our foreign policy, which has been so misdirected in the past 8 years? And if we perhaps took a less confrontational attitude towards China, that maybe we could work with them on this issue, which doesn't seem to be being explored right now.
Well, I think the potential for working with China and India is really very good. I think that, publicly, some politicians are saying, "Oh, we're not going to do anything until China does." Well, actually, China is, I think, very open-minded on this, and they are making efforts to find energy sources that will not produce carbon, and they will suffer more from the climate change than we would. They have a few 100 million people who live within 25 meters elevation of sea level. So, and they've contracted with ARUP company in the United Kingdom to make 5 carbon-free cities. Take decades to do it, but that's why one of the first things that I think the president-elect should do is get together with China and India and agree for technical assistance on the R&D for carbon capture and sequestration and nuclear power, so that we develop, because it takes so long to develop things in the U.S. It may be possible to do it faster in cooperation with China if we provide technical assistance to them. And that way have options for the future. But I think that there's great potential for cooperation.
In terms of cooperation, one question is, wouldn't a carbon tax to be really effective have to be global? I mean, can you do it in one country?
No, you're right. You cannot do it in one country. So you would want to start with at least a substantial number. But it's actually it's much easier to make it global. Because all you have to do, if China says, no, we're not going to have a carbon tax, then you say, well, we're going to have a border charge on those products which come into our country. We will put a duty on them according to the amount of carbon that's used in the production of that type of quantity. And the tax is then collected by the United States. So they very quickly will decide they would rather put a tax on and keep the money rather than let us have it. Because once the G8 or the main countries decide, okay, the several most important players, Europe and the US, decide we have to do this, then it will be allowed that you can put a duty on for a country that does not have a carbon tax. So as opposed to the Kyoto type approach, this will be much faster. It won't take 10 or 15 years to negotiate it. You can, once you decide on this tax, you can implement that quickly, and if you have to, you put a duty on the countries that don't have a tax.
Okay, we're gonna have to get Jim Henson off to his red-eye flight back to Newark, so we've got to end this up. What a motivational evening, and I hope you're all really inspired to take action against global warming.